All right. So section 11.2, or excuse me, 11.3. We did 11.2 on Friday. So 11.3, solving radical equations. All right. Solving radical equations. The key to doing this is to get the radical isolated by itself first. And if you do that, then these become much, much easier. Okay? If you don't have that isolated, then you're going to have some issues with solving this. Okay? So we'll start with some that are, already have that radical isolated or are very close to having that done. And then we'll build up to the more difficult problems. So first one, a radical, remember, is just a square root. So square root of x is equal to 4. Square root of x is equal to 4. All right. So what's the opposite of a square root? What's the opposite of a square root? What's the opposite of squaring something? To get rid of x squared, what do we do? Take the what? Take the square root. So the opposite of a square root would be squaring. Okay? They're inverses of each other. Okay? So if the square root's by itself, you will square each side, it'll get rid of it. If I square both sides, on the left side, the square root and this squared cancel each other out. All that's left is x. On the right side, you got 4 squared. What is 4 squared? 16. There's your answer. Once the radical is by itself, you get rid of it by squaring both sides. That's how you get the x by itself. So here we have a problem. It says 3 radical x equals 15. Is the radical completely by itself? No, it's got a 3 in front of it. Divide by 3. That'll get rid of that. So that's radical x equals 5. How do we get rid of the radical? Square both sides. Left side we get x, right side we get 25. Pretty easy so far. Radical x plus 3 is equal to 10. Yeah, move the 3 by subtraction. Get it over there with the 10 because they're like terms. The radical x is equal to 7. Now what? Square. What's x equal to? 29. Man, this is easy stuff. Oh yeah, it'll get a little tougher, but not too bad. 2 radical x minus 8 equals, let's go with 4. Which one? Can't divide by 2 yet. Gotta add 8, not subtract 8, but add 8. And then we have 2 radical x is equal to 12. Now we can divide by 2. Radical x is equal to 6. The last step, square it. X is 36. Not bad so far. You done? It doesn't get too much harder, but it gets a little bit more difficult. So we had 12 radical x minus 2 equals 1. Okay, so it's a lot like example D. So we're going to add 2. 12 radical x is equal to 3. Divide by 12. Does 12 go into 3 evenly? So what do we do? As a fraction. As a fraction, it would be what? 1/4. All right, good. Now, is the square root by itself? It's not?
Yeah, sorry.
Yeah, it is now. Okay. So how do we get rid of it? Square both sides. So if I square both sides, and I square 1/4, it'd be 1/16. Yeah, 1 squared is 1. 4 squared is 16. 1 over 16. No, I'm saying 1/4 times 1/4. Top times top, bottom times bottom. Because it's ones, it doesn't look like anything happened, but it did. So x minus 5 underneath the square root is equal to 6. Now minus 5 is inside of that square root. So why would I go ahead and square it?
To get it by itself.
To get rid of what? The radical. Yeah, the radical part is by itself here. Even though there's a bunch of stuff inside of it, the radical is by itself. So if we square right here, it gets rid of the square root. And we'll get what on the other side? 36 was just a regular number, right? So by squaring it this step, it gets rid of the square root. We cannot move that 5 at all until the square root's out of the way. Like it's locked it in there. That's the reason we got to square first. And then you just add 5, yeah. 41, right? So a little bit more to it there. You got to do something after you do the squaring. But it doesn't make it much more difficult there. Let's go a little bigger here. That looks really hard, but it's really not. Okay, so we're going to move the 12 because it's not attached to the square root at all, right? It's just the plus 12. So we're going to move it first. That's the right idea. It's going to be 4 radical x minus 7 is equal to 16. Now what? Divide by that 4 that's in front. We got to get rid of that guy. So divide by 4. Good. And 16 divided by 4 is 4. Now the radical is by itself. We can square both sides. It gives us x minus 7 is equal to how much? 16. And then, yes, you do add 7. Last step. 23. Good job. You could go back to the original problem and plug in. Since it's an equation, you can plug in the answer you get in the original problem just to check it, see if it works. They do. On this, so far, we haven't run across any that don't. So let's look at H here. So we had 2 radical 3x plus 6 plus 9 equals 21. Okay, we're going to move the 9. 2 radical 3x plus 6. 21 minus 9. 12, good job. Divide by 2, that's a good idea. Now we got radical 3x plus 6 is equal to 6. Square, because we got to get rid of the square root. To move anything else that's inside of there, we got to get rid of that square root first. So that's going to give us 3x plus 6 is equal to 36. Minus 6. Good job. And then Caden said divide by 3. X is 10. Not too bad. Once you get rid of the square root, it's back to stuff we did in August. Really easy, simple equation stuff. Okay. All right. Let's look at one that looks really hard, but it's really not. It's actually some of the easier ones you'll get to do. Let's say we had the square root of 2x minus 7 equals the square root of x plus 2. What would that do? Yeah, it'll get, if I square both sides, that'll get rid of that. Square on the left side will get rid of the radical there. But if I do that to the left side, I have to do it to the right side. So that gets rid of the square root on both sides. So that gets us that 2x minus 7 equals x plus 2. And how do we do what now? Okay, that's a good idea. 2x minus 1x is x. Still got the minus 7. It's just 2 on the other side. Plus 7. X is still not very hard. Okay. Let's get to one that looks really hard. Square root of 4x minus 3 minus the square root of x equals 0.
Subtract that one or add the one.
Okay, so I can get rid of this one. Is that what you're saying?
Wait, never mind. Subtract what I said.
Okay. I can't just square. If I square this, I'm squaring that whole side. So it would be this whole thing times itself again, which would be very, very complicated. Doable, but I think it makes it harder than it has to be.
Negative 1 on the square root of 10.
Okay.
So
How could I move this one around maybe to make it look like the example we just did? Because the reason I can do that is because look what's over here. Nothing. It's 0, right? So how could I move this one? By adding it, right? Because they're subtracting it. So if I add it to 0, what's 0 plus the square root of x? What's 0 plus anything? It's whatever you add to it, right? So 0 plus the square root of x is just going to be the square root of x. And on the left side, we got the square root of 4x minus 3. All right, then, yeah, now the square roots are isolated. So if we square both of them, that's 4x minus 3 equals x. I'm going to subtract 4x. That's going to be negative 3 equals negative 3x. Last step's divide by negative 3. X is equal to 1. So look for tricks like that, things where you can move one of the square root. If there's more than one square root, look to move one of them to the other side, because they're not getting into just incredibly difficult problems here when they put more than one square root with this stuff. You get to Algebra 2, they get a little bit more difficult, but they're not too bad in Algebra 1 format. All right, let's look at the last couple of examples here. These are the more difficult problems for this particular section. Square root of 6 minus x equals x. What are you talking about, isn't it? That looks like the same kind of problem we had before. Got one radical in it, so it's not as hard as the one that had 2 radicals in it. It doesn't look as hard. If I square both sides, it gets rid of the square root, right? That's what we're looking to do. If I square that, I get 6 minus x. What do I get if I square x? X squared, right? Oh, that's why it gets hard. Because it's got an x squared in it. If it's got x squared in it, then that means we have to solve it with one of the methods that we used in chapters 9 and 10. Either factoring or quadratic formula. Okay? To use either of those methods, what does the equation have to be equal to? 0. So let's move it over and get 0 on this side over here. So I'm going to move the 6 and I'm going to move the x. Subtract 6, add x. That gets everything to one side. There's 0 equals x squared plus x minus 6. Notice I wrote it in descending order. Because you need it to be in descending order so that you can do things the right way. Now, I have options here. I could either solve this by factoring or quadratic formula. We're going to solve this one by factoring, and we'll do the next one by quadratic formula. I don't care which way you use. If it'll factor, and you remember doing the X method for factoring, you're good at that. Some of you are really good at that. Use it. If you'd rather do the quadratic formula, that's fine too. I don't care which way you solve it. You just got to show me how you did it. Okay? So, for this one, if I'm going to solve by factoring, I do the x. 1 times negative 6 is negative 6. There's a 1 in front of the x in the middle, so that's a 1 on the bottom. We need something that multiplies to be negative 6 and adds to be positive 1. So what are the things that multiply to be 6? 2 and 3, okay? But to be negative 6, one of those has to be negative, right? Which one should be negative so that it'll add to be positive 1? The 2 should be negative, right? And remember when we were doing these back in chapter 9, in order to factor that, because there's nothing in front of x squared, you could go straight to x plus 3 and x minus 2. Because there was nothing in front of x squared. If there's something in front of x squared, then you're going to have to do that grouping stuff that we did. Okay? All right, now, x, what do we do with each one of those factors, x plus 3 and x minus 2? What do we do with each of those? If we multiply them back, we're going to get back to this blue step. That's going backwards. After we get them factored, we set them both equal to what? 0. Subtract 3. X is equal to negative 3. Add 2. X is equal to positive 2. Now, we got 2 answers. Normally, we don't have 2 answers. Every problem we've done up to this point only have 1 answer. We've got to check them. Okay, so if we check these answers, if I take 2 and plug it back into the original problem, I go all the way back to the original to check. Okay, so if I plug 2 into the original problem, remember the original problem was the square root of 6 minus x equals x. What's 6 minus 2? What's the square root of 4? 2. Is that what's on the other side there? Yeah, so that one works. 2 works. It's entirely possible that negative 3 also works, but it's also possible that it doesn't. Okay, if I plug in negative 3, what's 6 minus negative 3? Positive what? 9, you mean?
Yeah, sorry.
And then the square root of 9 is 3. But there's a negative 3 over here. Does 3 equal negative 3? Never. Owing me $3 is not the same as giving me $3, right? So if Positive 3 does not equal negative 3. So this one is thrown out. It's what's called an extraneous solution. That's the word that it's called. You don't have to write that every time. I'm just saying we found that answer, but it doesn't work in the original because of the square root. Okay, this is the positive square root of 9 does not equal negative 3. No, it's the positive square root because there's not a minus sign in front of it. All right. Okay, so the negative 3 is thrown out. The only solution we have here is 2. Okay. Let's look at another one. There's not a ton of these like this, but you still got to know how to do them. I mean, guys you got to remember, this is a math class. Everything builds upon the previous skills. So all this stuff's coming back. After we finish chapter 11 stuff, we go to chapter 12 stuff. We're back to factoring a lot. You still got to be able to factor. You go to Algebra 2, you got to be able to factor the first day you're in there. So we spent a month and a half on it for a reason. X equals the square root of 20 minus x. A lot like the previous example. Is the square root by itself? All right, so we're ready to do what? Get rid of it, right? By squaring. So if we square both sides, that's going to get us x squared equals 20 minus x. Right? Now, it's got an x squared in it. So that tells us we've got to get the problem equal to what to solve it? 0. Okay, so move the 20, move the x. But then you get a negative in front of the x squared, which makes it a little bit more difficult to factor or quadratic formula with, because you got an extra negative in there. So I always try to leave the x squared positive is what I try to do, because it makes it easier later on. So x squared plus x minus 20. This one could be solved by factoring. I'm going to do it by quadratic formula so you've seen another example with quadratic formula. Quadratic formula works every time. Factoring isn't always going to work. Sometimes you'll get polynomials that won't factor. I think our particular textbook tends to give you ones that do work out with factoring. But I'm going to do it with quadratic formula just to refresh us on that. Remember the quadratic formula? Negative b plus or minus radical b squared minus 4ac divided by 2a. Then I list a, b, and c. A is 1, b is 1, c is negative 20. I'm going to find the discriminant first. The b squared minus 4ac. Because if b squared minus 4ac is negative, what do we know about our problem? It has how many solutions? If the discriminant is negative, b squared minus 4ac, we don't have any answers. There's no real solution to that. If it's positive, we're going to have 2 answers. If it's 0, we'll have 1 answer. All things that we went over in chapter 10. Okay? So b squared, that's 1 squared minus 4 times a times c. So that's going to be 1 squared is 1. Negative 4 times 20 would be 80. So the discriminant is 81. So that means we got 2 answers to this. Of x equals negative 1 plus or minus the square root of 81 divided by 2 times a, which is 1. So this is the quadratic formula here that we're using. What's the square root of 81? 9. We know that. Right? So we have negative 1 plus or minus 9 divided by 2. Okay. Split it up. X equals negative 1 plus 9 divided by 2. X equals negative 1 minus 9 divided by 2. Negative 1 plus 9, that'd be 8. 8 divided by 2 is 4. Negative 1 minus 9, negative 10. Divided by 2 is negative 5. If I go back to my original problem, remember my original problem was x equals the square root of 20 minus x. If I plug in 4, what's 20 minus 4? 16. What's the square root of 16?
4.
That's what's over here, right? Because that's x. X is 4. If I plug in negative 5, what's 20 minus negative 5? Try again. Positive 25. 20 minus negative 5 turns into 20 plus 5, which is 25. What's the square root of 25? 5. But over here is what? Negative 5. Does negative 5 equal 5? Never. So that one's thrown out. It's what's called the extraneous solution. It's extra. Okay. A lot of times the negative ones are the ones you'll throw out, but it's not always. Sometimes you will keep the negative. Sometimes you'll keep both answers because they both work. But most of the time, if you're going to throw one out, most of the time it's a negative answer. Okay? So it's the negatives are thrown out more often than the positive ones, but you won't always throw out the negative. You got to check it in the original problem. Okay? All right. This is what we're going to work on today. About 25 problems. Oops, 27. Most of them, the majority of the notes was not the harder ones where you had to factor or use quadratic formula. The majority of the practice problems are not the ones where you've got to factor or solve by quadratic formula. So keep that in mind as you're working. The only time